So in this video, we're going to talk about hypothesis testing for population proportions. The test statistic for population proportions is as follows, where P bar or hat is the sample proportion, P naught is the population proportion, divided by P naught 1 minus P naught divided by N. This is the form of the alternate hypothesis. This is the critical region for which the test hypothesis is the alternate hypothesis is accepted. This test statistic is for testing population, the difference between population proportions of two populations, which we'll go into the next video. Let's look at our first example. Research conducted a few years ago showed that 35% of UCLA students had traveled outside the US. UCLA has recently implemented a new study abroad program, and results of a new survey show that out of 100 randomly sampled students, 42 have traveled abroad at 5% significance level. Is there evidence to suggest that the portion of students of UCLA have traveled abroad has increased after the implementation of the study abroad program? Well, in this case, our null hypothesis is the fact that the population proportion is less than 35%. Alternate hypothesis is the population proportion has increased. So this is a right tail test. This is a right tail test. And our Z alpha here is set 0.05 since we have 5% significance level. And 0.05, so let's clean this up. 0.05 is right here. So 1.645. Now let's calculate our test statistic. Remember, it's sample proportion minus population proportion, or P naught 1 minus P naught divided by N. In this case, we have 42 out of 100. The sample, the travel abroad minus 35% divided by P naught 1 minus P naught, so 0.65 divided by the number of students sampled, which is 100. So we cut that into our calculator, we get 1.47. Note that 1.47 is less than 1.645. Which means that our Z statistic does not fall into the critical region. So we accept, or we do not reject each time. That is, we accept the null hypothesis. So therefore, there's not enough evidence to support the claim that there's an increase in the number of students going abroad due to this new study abroad program. There's not enough evidence. To support increase in number of students going abroad due to this new study abroad program. Okay, so let's go to our next example. Stateville College claims that 94% of the graduates find employment within 6 months of graduation. In a sample of 500 randomly selected graduates, 475 of them are employed. So in fact, this is a typo in the original lecture 10 notes. It should be 425. And I've remedied that in the new lecture 10 revised notes. Is there enough evidence to support the college's claim at 1% level of significance? So in this case, our null hypothesis is that the college claims that 94 yep, so status quo 94% of the graduates get employed within 6 months. The alternate hypothesis is that less than 94% of their students do not get employed within 6 months. Get employed. So this is a left tail test. So that means we need to look at minus z alpha, which is minus z at 1% significance, 0 0.01. What's 0.01? 0.01 is about right here, so 2.325. 325. Let's calculate a z statistic to see if it's the left or right of this minus z alpha. It's percent proportion, which is 425, 500 minus the population portion divided by population portion 1 minus population proportion divided by the number of samples. So once we plug that into our calculator, we get minus 8.474. So we compare the z statistic to z minus z alpha 2. We note that the test statistic is less than, is outside, is in the critical region. Okay. So this implies we reject the null hypothesis and accept the alternative hypothesis. Therefore, there's not enough evidence to support the college's claim. And let's look at our last example. A cigarette manufacturer claims that at 1/8 of the US adult population smokes cigarettes. In a random sample of 100 adults, 5 cigarettes, they will find 5 cigarette smokers. Tests whether the manufacturer's claim is true at significance 0.05. So in this case, our null hypothesis is just the status quo, that is 1/8 of the population smokes cigarettes, that's 1.25. Our alternate hypothesis is that is not equal to 1/8. So since it's a two-tailed test, then we need to look at z alpha over 2. In this case, it's z alpha over 2 is 0.025, because it's alpha is 0.05. 0.025 is at right here, 1.96. Okay, so let's calculate our z statistic again. Sample proportion. So 5 out of 10, 5 out of 100 were sampled to smoke, minus 125 divided by 0.125. Population proportion, 1 minus population proportion divided by the number of sampled. We put that into our calculator to get this. Minus 2.27. Okay, so remember what the picture looks like. Here is minus z alpha, which is minus 0.6. This is z alpha. So this test, the statistic is outside the region where we accept H0, or in the critical region. So therefore, since the z test statistic less than minus z alpha over 2, then we reject the null hypothesis and accept the alternative hypothesis. Therefore, there's not enough evidence to support the manufacturer's claim. Okay,